Hello, hi. Anyway, hi, back again. This is called Sloppy Game Dev. This is the 5th installment of live streaming of me trying to make a game with Claude, or with the help of Claude, using my graphics engine called Hotline, which is written in Rust. I'm trying to make a train station simulator game. Before I start, I wanted to talk about that. I kind of did a little session on this without Claude in midweek, because last time I was getting a bit frustrated about the code Claude was generating, and that I was struggling to understand what its code was doing, and then I was struggling to basically prompt it to solve a problem. And that has led me to some insights and some thoughts about, like, why what it is essentially is that if you're just asking AI to generate the code for you, you lose the intuition of like the problems you're trying to solve, and then how you can't tell it to do things that you don't know. And Claude isn't just going to magically figure stuff out. Like it is good at some stuff, but it's not, it can't just one shot this game, which I showed clearly on the first episode. So basically, this is dev mode, and this is the game. I've tried to up my settings a little bit because I was noticing when I looked back at the stream just to kind of evaluate it. Some of the stuff, it's kind of video compression makes these lines and things hard to see. So basically, the first attempt was this, right? And this was kind of like, tell Claude, I want to make a game. These are trains, these are barriers, these are people. Look, they've got bugs, It's got bugs. It just did this, right? And that was from prompt trying to explain what the game is. And this is what it made. But the code for this was all very, like, hard-coded. It's loads of, like, all of the train position and stuff is here. It's basically hard-coded. And, that's not good. You can't make a game because it's just hard-coded stuff. You need to make things like, it needs to be data-driven. You need to be able to make the map and the level, and you need the ways to interact with it. So this was it, just purely vibe coding the whole thing. And then, so now I've gone back to basics, and we've kind of started again. And this is the second attempt, where this is a tile map. This is a train platform. These are walls. And maybe I'll show you what the problem I was having last time was if I put Claude's code back in, and then we can put my code back in, and then we can essentially compare the two, and I can explain what I did in the midweek on my own, which the code is not... Basically, it's by no means complete. But I've learned what I need to do, basically. Let's put this into here, and let's see if I can get my code and Claude's code interchangeable, so I can toggle between them. I probably should have set this up before doing the live stream, but that doesn't really matter. This says commented out Claude, right? Because that is what I did. I commented out Claude's code, and originally I just wanted to understand the Claude code and what it was doing, because I was struggling to, basically instruct Claude what to do. And this is going to be inside a true thing, and that's my code. Okay, so that's Claude's code. Well, I can do that else. Oh, leave it. Right, okay. I think we need to This might not work. Is it compiling? Right, it has compiled, but I think it might not work. Yep, they're not updating. So I need to change the color of them, actually. I was noticing on the stream that orange color's kind of a little bit difficult to see. Agent call. Something a bit more contrasty. Maybe just red might be better. And we're not actually updating the position of the agent at the moment. So pos p equals that. Did it make pos equals pos plus total vel? Right, let's see if this works. Right, it's compiled. Okay, right. These are agents, AI agents, and they move through the map. And they kind of get stuck on the wall, and they're still getting stuck on the wall, right? So, you know, basically, these guys get stuck on the corners. And even after prompting, saying they're getting stuck, and Claude's like, you're so right. Let me do this. It should be fixed now. And then you'd run it again, and they'd still be stuck on the wall. And the only reason they actually get unstuck from the wall is that they have a kind of slight randomization, like a wander, you know, because I wanted to create a little bit less rigid movement. And the wander actually eventually moves enough that it kind of sort of gets them around the corner, right? I actually thought it had done a better job than this, but this is actually pretty terrible. And quite annoying, right? And so let's see how much code this... Right, basically all of the code in this statement, this true statement, is to do with trying to resolve getting stuck on the wall, right? And then the collision detection as well. The collision detection, right, is kind of, we need it, but basically it's like all of this stuff. And what it's done as well, which is quite annoying, I have a maths library which has clamps, and I have kind of freestyle functions, shader style maths functions that I'm using elsewhere in this code base. Claude is just using the Rust kind of standard library ones, and it's kind of expanding vector math, right? You know, there's a vector clamp, and it's doing X and Z independently, which is annoying. And so, you know, math code basically, or maths code, because I'm English and we use S on the maths. Basically, you know, it's kind of doing a dot product here. Look, it's done dot product manually. You know, there is a function it can call that does dot product, but it writes out dot product. It does it for other things. It writes out magnitude. You know, here, this is a magnitude looking thing, right? Square root of dot. And that's kind of annoying because it's not easy to read. Like, if this wasn't called dot, I'd look at that and I'd go, oh, well, you know, obviously it is a dot product, it's multiply and add. But, you know, if you're looking at a load of code, you're like, oh, what's it doing? Obviously the dot there is a bit more intuitive than this, which is, this is a magnitude. And so the code itself is horrible, right? This is not nice code. I don't want to work on it. I felt, you know, but what I was in a rut because I was like, your code isn't working. So it's like, oh, I'll write all of this. I don't know what this is doing. Well, it says here, project velocity to, you know, along the wall. Okay, so you project the velocity on the wall, speed preservation. It's you know, there's quite a lot of code there. Renormalize it, then do this, right? So then I got down to basically my equivalent version, which we can enable. Let's swap it around. And let's see how much better it is, basically. Basically. Oops. Just checking the stream's on. Yes. Okay, cool. So no chatters. Right. So now I've switched it onto my version. Let's put some agents. And I'm drawing some debug lines, and they kind of, you know, they smoothly, look, more smoothly go along the walls. And they don't get stuck, right? They do not get stuck on any of the corners. And they have some nice smooth velocity to get them away from the wall, right? So I'll explain how that works. And, you know, basically part of this, what I was doing, you know, I'm drawing debug lines, I'm drawing the walls. I changed the collision system. So basically instead of colliding with a tile, you collide with a line, which is the wall. And then that means it's a bit more of an expressive way of doing collision than just colliding with a tile. Because you could have, you know, diagonal walls or curved walls made out of lines. I'm not saying that I will, but I think the primitive of using a line for the collision has some nicer properties we can use. And I can draw that kind of in, sort of show you. And I need to, got my mouse screen drawing thing on. Zoom it, which is quite nice actually, and handy for stuff like this. And do we use Control and 2? Yeah. Hey, it only goes on the one screen, which is annoying. Oh, for God's sake. Here we go. Okay, we've got one, finally. Right, so if I'm in this square or grid tile, I have a potential collider of this wall, right? And then when my radius intersects with the wall, oh, what the hell, man? I don't want it to zoom. Oh, no. Disaster. Right, I need to get better at doing this, but this is the way to explain how to do it. But that's quite annoying, that it fucked up. Right, okay. I'm in here, and if I've got this and I collide with it, we move we move back this direction, right? And then we put the radius of the agent outside the wall. That's how collision response works on a basic level. And then what it means is if I had velocity going in this direction, I kind of lose that velocity, right? And so when we come to basically colliding on the corner, what I realize is you're actually in this square. So at first, there was no collision, right? Because I was only checking, like, does this one have a wall? Does this one have a wall? Does this one have a wall? Or does this one have a wall, right? So then I was like, okay, let's get the corner tile. Like, so, if if I use these neighbors to have like a 3x3 neighborhood around our target grid tile, then the discovery I made, it was like, well, it's obvious when you talk about it, you're like, there's 2 walls that are here, right? There's 2 walls, and that means I'm on a corner. Okay. So then that gives you some insight into how to, it's like, I'm dealing with a corner collision and I was stuck on a corner. Also, what you can do is if you treat this so you've got this corner point and you treat this wall as a vector, it has direction. Basically, you can have the direction is going along this way, but this is in our case, it's the perpendicular product, points away from the wall, right? So based on the wall's direction, we know a vector that points outwards. So then what I figured was, like, if I do a dot product of the velocity, so the velocity of the agent at this tile, it wants to go this direction to find the goal, and this direction. If I do a dot product with this one and this wall, and they're basically the same, so the value equals 0. So if we say this is A and this is B, then, like, basically, if A dot B, not D, is equals to 0, then what we know is we're trying to go in we're colliding in along the wall. And what we actually want to do, we don't want to kind of resolve that collision. We need to shift ourselves along the perpendicular product so our entire diameter clears the wall, right? We don't want to just place ourselves outside of the collision. We want to make sure we clear the wall so we don't collide with it or scrape along it, right? A person doesn't want to scrape along the wall, So we can use this vector to basically, it can be used, and it is used, and you'll be able to see it if I drop some agent in. You can see this cyan line, or you might not be able to see it because if it's on the stream. But basically, you can see it kind of has it sort of pushes itself around, right? And it needs a bit more smoothness. It could look ahead a bit further. But basically, I figured all of that out, right? And this is why I think that it's important to talk about this, because just one-shotting or just the number of lines of code that you're slopping out using an AI agent or an actual, the coding tools is not a good metric, and that the objective shouldn't be to just slop out as many lines of code as you can. What you should be doing is thinking about how you solve a problem, right? And by just telling Claude, they need to move along the flow map. Oh, they're getting stuck on the corner. They're still getting stuck on the corner. They're still getting stuck on the corner. From that discussion, I didn't have enough understanding of the problem to be able to say, I could now go in and I could tell Claude, they're getting stuck on the corner. We need some velocity along the perpendicular product of the wall vector so that we can clear the side. And I could tell it to do that, and it could then do it. But if I don't have the context to give it in the first place, it's not just figuring these things out, right? And I don't understand, people say I'm doing this and I'm just one-shotting all of these things. I don't know how, because last time, to try and build this movement system, to try and build the flow map and the AI agents, and to get them to move, I basically, I spent about 2 hours of plan mode, of changing the plan, and it took ages. And even then, the code it generated was not nice. Like, it's like, I don't like this code. I don't like the way you've done the maths. I don't like the way you've expanded it. And then, I said use vec2i, and then it kind of does for some things, but it uses vec2i when it has to, because it has to pass it to that function. But then it does the maths, and then it's like, okay, no, don't do that. And what I'm doing then is like, we're not even at the point we're thinking about the actual problem we're solving. We're dealing with semantics of like the style of code Claude is producing here is fundamentally not code that a human person would write, because you wouldn't do it this way. You go, I'm not going to write a dot product every time. I need to use a function, right? But an AI can slop out the dot product every single time because it's not, it's not typing it, right? So that other metric of like, my AI code generates 75,000 lines of code a day and I'm shipping that. Yeah, because it's expanding everything. You're not, the smarter ways of working. And what I'm looking at this when I'm actually being critical of it, it's like, this is not that good, right? For this particular problem. For some other things, like I can show you some examples. So in GFX RS is a front-end graphics, like an agnostic graphics API. And you have stuff in here like all of these match statements to DXGI format, right? And there's a load of them, and it's like basically taking a generic type, which is used in the code base, and translating that to the DirectX equivalent, right? And then you have the same thing in here for Metal, for the graphics API Metal. So we've got all of these conversion functions, right? Claude absolutely just one-shots these kind of things, one-shots the backends, because it's kind of like interpolating, and that's what the LLM does, right? The way it uses the vector space of tokens or words, and it can kind of, like in different languages, the same concepts are clustered together, and you can kind of rotate them so they match, right? And that is exactly what it does, and that is what it is brilliant at. But I think when dealing with complex, kind of abstract problems, it's not about writing code. It's about thinking about how you solve the problem, building the intuition around it. And I'd lost that connection with this code. I looked at this and I was like, ugh, I don't want to look at it. I don't want to touch it, right? So that's a bad start. We're not collaborating there. What Claude's generating is not something I want to touch. And this happens, this is the same thing. It's got that expanded math manually done, even though I have functions which can do this projection, right? Basically, in the math library. And I just kind of went away and accepted it because I wanted to see the outcome. But once you have that code, then that's yours to maintain. And then basically, it's like a time bomb or a tech debt. You're building tech debt immediately. I think a lot of the code in here I don't like that much. The way that we have these tile names and place names, and these kind of things should be data driven. It doesn't suggest that to you, so you have to say this should be data driven, right? And that's part of the prompting. And I'm not saying, I've found these tools to be amazing, but I'm trying to explain situations here that I think I find it difficult to work together with it. It's either like you just go all in on the generated code and you keep prompting and you try and prompt your way out of it, because you feel like, oh, I don't like this code. I don't, the way they've got tile names and place names, but really they probably should be enums, and we could derive the name, instead of having this separate list, we could have a macro that does the derive and we can get the string from it maybe. I think there's probably, better ways to do that. So we got tile types. And if we did derive debug, we could put that into a string, right? And then we could use them. And then we don't have to have a separate array. But Claude didn't explain that to me, and it's kind of like, cool, I can do that. I can just write code because I'm fast at writing code. But a human person wouldn't do that because it's slow. And it's more stuff to maintain. It's more point of failures. This is an example. There's loads of Morton code, which is for the tile indexing. I'm using Morton Z order, and I have code for this in the engine, and it's just generated it again. And I've let it do that, but it becomes tedious to constantly be saying, no, don't do that, don't do that. So on a limited scale, I found Claude to be good at like shotting out bits of stuff I need. Anything complex, absolutely, I have not, been able to get it to do what I want it to do, or implicitly understand what I want it to do. So, where are we now? That's a lot of chatting, but that was like, I don't know, a philosophical thing about like AI code. I'm still not that, like, it's impressive, but also rubbish at the same time, still, right? And that's my stance on it. Somehow it's weird. But it can do some things. So what I think I've got now is the intuition of how these collisions work. And, I think that we can use that to our advantage. And then we can get Claude to do some stuff to help us tidy it up or make some changes. I think what I was noticing on the stream, because these are drawn as circles, we should still have the circle, but I'm thinking maybe we draw a physical geometry. Just got a text message to reply to. So yeah, we can use Claude to help now build this insight, but I think what's important is that I want to generate code that we can collaborate on together. And that's what I'm thinking is quite difficult, right? But I think that what we should be doing is... Right. Oops. Right, so based on now what's happened, so Claude's decision was we collide with the tiles, and it's just a square, and it was like doing min-max AABB kind of collision detection. And I think the lines are better, but I was generating them on the fly just for quickness while I could explore the problem space and build my intuition of how these things should work. Now, the goal is here for the AI agents, for my agents in the game, they're called the same thing, get them to go to the destination. And they actually do, they slide on the walls. These ones are stuck because they actually don't have velocity outside the, like now they have a velocity and they'll get there. And so... there's no sticking, which is quite nice. Yeah, this is the objective. This is the game. They would follow the flow map and they would get to their destination, which is the yellow squares. So what I want to do is I need to pre-bake the collision primitives, which are lines, into the tile. So as I'd showed before, obviously in this tile, these are our collision walls. Because you can, technically you do have the corner. These ones, like actually this wall here, we can ignore, and then for this tile, there would be, obviously that would be just one collision wall, and so on, right? So at the moment, I just generate these. Oh my god, that again. That's how it works. That's quite handy actually for the stream. But also at the same time, I can't scroll and zoom. Just figuring out these things. So my streaming skills are a bit basic, but this is only the 5th one I've done. And I've had a few views, but not much comments, so it's more just like historical. But when this game is working, then people will be coming back and looking at this content and going, wow, how did you figure out how to do all this stuff? And I will be telling you. So, basically, wall collisions, I was just generating them on the fly. Where is that code? Where is my code? Walls. So it kind of does a single axis and then it does the corner. I don't believe I actually need both of those passes. We just need the tiles of the wall, the walls of the neighboring tiles, and then we can do the magic code, which is the dot product with the wall vector to check if you're basically, it's not parallel, it's just like directly going in the same direction, and then we take the orthogonal vector, which is the normal or the perpendicular product, and then we can steer around it. So we would have that logic baked in on every wall, and we wouldn't have to think about a corner. We're just thinking about, you know, I need to make sure my entire radius clears that wall, or my entire diameter, so I'm not intersecting a wall. So basically, yeah, this I've got this like little code which is like, you know, these are the tiles, and then it calculates the wall vectors. So they need to be baked into the map, and then we can just look them up. So that's one task to do. This and then what I was trying to do is do multiple tasks at the same time, to kind of, you know, have some work that I can work on, stuff Claude can work on. But it's kind of painful because, you know, it's sort of like, basically, I have to check it carefully, you know, and it's hard to multitask. So I think I'm not getting any efficiencies there because, as I've pointed out, for this particular problem, Claude can't go away and just do what I want it to do. I have to be telling it. So that leaves me a bit like, what should we do now? I think that maybe I'll get Claude to do something quick and small. Can we add a geometric mesh? So basically, I think on the stream, then it'll look a bit better, and you'll be able to see the agents to the in-game. Started doing that again. My mic has some kind of annoying crackling, which is bad vibes. It was fine. So what I want to do is add, so that these guys, where are they? I want to add these guys so they're not just a line, you know, a circle outline. I want them to be an actual geometric mesh, and then they'll probably be a bit easier to see in the game. We could use, I think, just like basically a cube, but stretched. So So they're like tall and, you know, kind of human proportions. So a geometric mesh in the game, it can be a cube that's scaled in the y-axis to make them taller, you know, like humanoid kind of proportions. Proportions, right? The actual cube can be smaller than their radius, or should it be the same size? Let's see what it does. I'm not going to tell it. And let's just go into plan mode to ask. I need to get a new mic and stuff because this one's crackly. And improve my setup. I could do with lots of stuff to improve my setup. So yeah, first thing, I just want to make these guys a bit more visible. And then what I actually want to do, before we bake in the collision primitives, I want to actually have because these are overlapping, right? Can we pan? No. I don't know how to... So, yeah, basically, if we look at them here, they overlap. And I want to have actual collision, proper collision separation on the radiuses of these guys. The radiuses might be different sizes, but originally it didn't have, you know, collision with the walls. So that was when, oops, well, that doesn't really matter, but basically, before they were intersecting with they weren't in like being moved out of collision, and they would intersect with the walls, and then by adding the collision to the walls, then they started getting stuck on the corners. So I want to add this kind of collision constraint between the agents. So we can, you know, maybe have to resolve some finer tuning with the collision of them, and then we can kind of build the collision system around something that works. If you notice all these things being drawn, they're a little bit flickery, and that's because there's jitter in the position. So that's another thing I want to sort of think about, is how to stabilize things so it's not jittery. Or maybe jittery is fine and we can resolve it at the end. Basically like how you do temporal anti-aliasing, where you could have a history and then smoothen it over, that kind of thing, to kind of average out the jitter. But it could be something like, if these have a collision, then it's going to be kind of iterative, because, you know, you have to solve. It's like a solver, right? And I don't know that much about those things, like constraint solver. Let's see what Claude's plan is. Hey, I can't see it. Select text to... This is... I don't really think this is... should be. Let's see. It's kind of small. I don't know why I didn't display it in the normal window. Renders as octagon wireframes for imdraw. Goal is to add 3D cube mesh. Scale human portion, tall and narrow. Stylize humanoid characters. So it's a mesh component, it's a cube mesh, agent mesh, it's a resource, create a cube mesh, add that. Do we have the scale? Agent, half body width, half height. Okay, well, that was fairly simple. Update agents, transforms, half body height. So yeah, that's kind of fine. Update agent transforms. Okay, that's fine. We can say yes. Oh, that's another instance. Okay. Yes, and auto accept. I think the plan seemed decent there. It did actually do the code examples for me, so that's nice. So yeah, once we have that, it should be a little bit better to look at on stream visually. Because the lines are thin and, you know, not very resistant to compression artifacts. And then once we have, so now it's gone back to the original map. I think I need to make a new map as well. So then the second thing is we only have single directional flow at the moment. And this might be hard to see on the stream. Couldn't it go? Annoying. This is annoying. So the arrows. That are pointing in the flow direction are all flowing towards this, which is a train platform. And this is how the game would work. But there's something that makes the control button not work. And now it does. So that I'm blaming Claude for that as well. No, it's weird. It's like I have to use it. Oh, for God's sake. Anyway, I'm getting sidetracked here. Basically, the flow of all of these is pointing in one direction. I need actually two flow maps or multiple flow maps because, say, if we added another platform here, we want to have, you know, basically a flow map which they're basically just going to the closest one. But which is handy because you might want to have multiple kind of like things that are the same goal. And they'll, you know, people would then naturally go to the closest one, which that's what people would do. But we want to have, you know, people leaving the station and people going into the station. You know, you want to have different goals. And then once we have that, then you're going to have agents that go opposite directions, and that's going to cause some different kinds of collisions. So let's see if the agents, Claude's saying that it's done it. Oh yeah, okay, right, we have a person, right? Why is it doing that? Let me restart this one. Oh, for God's sake. Agent should be the first thing we place. Oh, that was weird. That going in the other direction, they were colliding. earlier, right? So that seems like a bit of a bug. But now they're a bit more visible, right? The people, the agents, and that. It's changed their collision radius, I think. Or has it? That's the separation. Yeah, see, they're intersecting. Okay, they are intersecting. So I want to prevent them from intersecting. That's kind of an objective. And then once I have them intersecting, let's see if I can get Claude to sort out my issue, because this is sometimes the zooming breaks and the control key, or is it my control key might be just dodgy. But yeah, I think Claude did that then, and I checked the code, so that was fine. I was complaining about it before, I was complaining about it last time, I was criticizing it, but it can do some stuff. I think it's that you have to build a better understanding of how we can work together on this problem. But now I can't see my velocity vector. So this doesn't really matter. Right, but what I'm going to do now is let's go into plan mode with Claude. Okay. So what I'm going to do is I'm going to say we're going to make collision. I want a hard, like sort of collision constraint to stop the agents intersecting one another. So maybe like, do we need a? I was wondering, do we need like a multi-iterative solver? So I don't really know about this. Like, I've done like quite a lot of collision detection and simple collision response, but I've never really done full physics systems. The sort of yeah, I would like the sort of positions to be stable, where currently they are a little jittery. So yeah, let's see if Claude can help with this, because this one I was actually finding just this, sonnet on the chat to be quite nice to ask things like this and to discuss ideas for the game. That's how I designed the flow map and the original high level aspect of it. And I think that's another thing that's still, before I was using Claude, I was using ChatGPT at work, and I would just, ask the chat, and I would kind of code, then write the code myself, but I would ask it for like, how do I do this, or what do you recommend, And I think that's a different relationship with coding, where it's like you're still doing everything, whereas the full-on agent inside the IDE is like, it detaches you from the problem and it changes the way you're thinking about it. You're not thinking about solving the problem, you're curating what Claude is doing, and it changes your relationship with the problem, which I think, and I think then I think you need to do both, and then you can then give it good instructions and where it's going to succeed, and you're like, I need you to do this, and it can just go away and do it, And then for the things like the collision system, Is like I needed to know more about that problem deeply before I could tell Claude how we're going to solve it, you know. Yeah, at this point, the control key is not making the zoom smaller. That's a... while Claude's doing that, I'm just going to have a look. I should probably learn the shortcut for that maximize. What is it? Control K, Control M. I don't like a double shortcut, you know. It's Control K, Control M. Okay, not bad, actually. That's not too bad. Right, curl. Sys key down, curl. There's a lot of curls. This is probably one for Claude, I would say. Ooh. No! No. Oh, look. What's it looking at closest point on line segment for? Yeah, sep force. So sep force jitters, definitely. But we need to resolve the collision first, and I think that was probably a bad decision and a bad prompt. Maybe it does resolve it. I'm just going to check the footy scores. Tottenham are probably going to be losing, and they're going to be relegated. Oh no, it's not kicked off yet. Well, you can't lose if you're not playing. Right, okay, so here we go. Hard agent collision. Agents use soft sep force. It's far too weak to prevent overlap. No, a simple per agent iterative position correction using a snapshotted position table is sufficient. This is the standard position-based dynamic style approach without complexity of a global solver. Okay, so that's nice. It's saying we don't need this iterative solver. The current system is jittery because of the sep force. So add a constant. It bloody loves constants. Everything. Put in a bloody constants. I suppose it is correct to do that as a const, but I don't know. Just I see more consts in Claude code than any other code I ever look at. Because also I would put them more locally in the function, you know, like so above the loop. And well, in C++ I would make const expr, because then it's more local to the code that you're looking at. And you could give it a name, you know, iteration count, and then it's there if you want to change it, or you can see what it is. But anyway, that's a minor detail. So we add correction iterations, so they have a few. Between the mouse hit computation pass, which is irrelevant, which is also annoying because there's sort of UI related stuff in there that, you know, is for debugging that's mixed in with the main agent update logic. Position correction, right? Hard contact constraint. Push new pos out of all overlapping neighbors. So, world to tile. Get agents at is. I think the Already it smells bad. Smells bad. Just instinctively. So one iteration does 2 agent contact perfectly. Dense clusters need extra passes to propagate outward. 4 is a standard sweet spot. Interesting that it knows that. So what I'm not sure about is this get agents at. Does that already exist? It does. Okay, so get agents at gets me all the agents at the tile. But the thing is that we're going to intersect neighboring tiles as well. So yeah, so for each tile, oh, mate, it's not that enjoyable reviewing the Claude code. So what we do is, hold on, new pause is, I don't think we should be doing this per agent, because we should be doing it per tile, right? Per tile, we resolve all the agent collisions in the tile, because we already have the agents and then we do them together. So that's what smells bad about this, because for the current agent, let's put one in here, for his tile, he then finds all the neighboring tiles and all the neighboring agents. We should be able to index that list quickly and just say, at this tile, for each tile that contains agents, resolve their collisions. So I think we need to just say, here we go. No, I'm thinking looking up per agent per neighbor to find all the other agents seems inefficient. Could we check? Could we do the work per tile and then resolve agents, each agent within a tile or a 3x3 neighborhood? Because that's kind of, we're always going to need the 3x neighborhood. I don't really know. I mean, this is the problem now. It's like, I'm like, yeah, I do want it to be per tile instead of per agent. But I don't know, it's this is the problem. Like, I'm asking Claude to do it and I'm not building my own intuition of that. I think for certainly what I want this to have, like thousands of characters in there, and it's handling them, you know, handling decent numbers of them fairly well. But I want to be able to potentially have tens. I would love to be able to have hundreds of thousands or millions of people, you know. Well, maybe that's probably excessive for a train station, but tens of thousands, I think, would be a good thing to aim for. I'd like to know how many I've got in there now. Right, so hello, one person watching or two people watching. I'm making this game, and my current objective is to stop these characters intersecting one another. Good point. Iterating. So this is a thing. It's like good point. Iterating per agent per neighbor is essentially the same. Lookup is done twice for each pair. A dedicated per tile correction pass after movement, where each tile processes its own agents against a 3x3 neighborhood and accumulates the corrections Jacobi style, which I like that. Jacobi. A Jacobian, is it? Is it the Jacobian matrix or Jacobi style? Jacobi, right. This is sounding good. This is the thing with Claude, though. It's like, it sounds plausible, but is this the new one? Stable. Does this include ready for review? I don't think it's actually... Why per tile instead of per agent? The 3x3 neighborhood is built once. Okay, so let's see how it's going to do this. So separation vel from total vel. And then we do that separately, which is fine. So that means that we're separating. We have velocity, which we're moving on the map. We have a collision resolve per... That should be per tile as well. All of this should be per tile, because we're going to want to have the same collision primitives in memory and all of that. Corrections, hash map. Right. So we iterate for chunky in map chunks. We're doing a fair bit of iteration to find one. Right, so we basically, if we don't have any agents, we can continue. I think there's probably another way. So instead of finding them... Oh, mate, this is the problem that I'm having with Claude for this particular project. It's a lot of, like... You know, it's... Now I want to change this again. And then I end up kind of doing that quite a lot. And then basically, I can add a comment. This is interesting. So agent correction pass resolves per tile. At the moment, let's have a look at the per agent movement and collision detection. I mean, I can't even... Right, this was the Claude's old code, which I'm getting rid of. And I'm just rolling with my own. I demonstrated the improvement that I made from doing this myself. And that becomes that. So... New pause. So collision is here. Collision and wall avoidance. Right. So for each entity, we do collision and wall avoidance. And for cell in occupied, what is occupied? What is occupied cell? Tile and cell agents. For cell in, so here we go. It's not using this. We already did this. We already did stuff before where I was like, do it per tile because it's going to be faster in the long run when we have a lot of stuff going on. We're going to have loads of tiles that are empty. So we already have a path, code path, which basically puts all the agents into a lookup thing where we have an array of entities in each cell, and then we can look at, we can basically look up properties of the tile. Even though doing that was, you know, I had to kind of steer it, snapshot the neighbor list. So yeah, we already have this code, but it's some of the same kind of code, because what's this separation? Which we're already doing it, which is weird. It's like, it's doing another pass. It's confusing because, you know, this code it's generated is not, you know, it's hard to get your head into it, and then it's hard to steer it, and then when I'm steering it, I'm like, oh, don't do it like that. But I don't know, like, basically we already do the separation per tile, and gather occupied tiles and agents within. What Claude was saying was it's going to collect them and then iterate over and then find the chunks, apply all the corrections simultaneously and write it back. Can we, like, so can we use the occupied cell stuff instead of like iterating over all the tiles? It's like we want to do it per tile, but we want to ignore the empty ones. Over all the tiles to sort of find occupied ones a second time. So I had this is the thing. Last time it went ahead and it was like, okay, I want to do separation, and it does it per agent for each other agent. So it's like, you know, you've got an n squared or an n squared, or not n squared, is it? Yeah, it is n squared. You've got an n squared out, like time complexity. And so I was like, do it per tile, and then we can bucket the agents per tile, and we only do the work. Right, the occupied vec2 is already tile grouped agents. We should reuse it. The common theme I'm finding here is Claude is terrible at reusing code. It doesn't think to go and call a function. It just generates it again itself. This is a real big problem. It doesn't, you know, I was talking about it before. It's like it doesn't use a dot product. It just writes the dot product every time it wanted to use it. And I said in the Claude MD for this project, it's like, use the maths library. But then it's like, you know, this is just not the way a human would think when they're coding. You wouldn't do that because you'd be like, we already have this information. That's part of that is laziness. I say I am an extremely lazy coder, but that's good because I generate less code, and then that's easier to maintain. And ultimately, I think humans would do that, whereas Claude is just, it's generating lots of code because it can do that quickly, but that's not good. That is not good. It's not good for performance at all because you would be doing another algorithm, completely redundant scanning of this grid multiple times. It's not good for maintenance, and it's not good for collaboration because that code gen is completely like different to what a human would write, and so it's alienating. So per tile instead of per agent. Is this the same plan? Is this another one? Corners, get rid of that. Distributed zooming balloon. For selling occupied, build a 3x3 neighborhood. For each entity. This one looks a bit better, but also, you know, I think the problem now is that I'm like, the initial stuff it generated, I was like, I don't like it, change it. Then I've got this and I'm like, can I really be bothered studying this? I just kind of want to see if it works. But then the problem is if I do that, I just get this in and see if it works, then I'm stuck with that code. And then I have to figure it out again. It's using the dot product now. This square, it's using square root on a float. I would prefer the math style functions of my engine. So I want it to get, basically I can do use the maths RS. Can I do this? Edit it, sir. This is a weird preference, just that I like shader style math functions. That's kind of what I like, you know, because I like shaders. And that this is actually quite hard to do in Rust, but you can make it happen. And this is a kind of like overloaded function almost through some weird, well, not weird, but generics and stuff. But I added comment on there. But it's using the dot product, which is good. It's using vec3f, which is good. So the memory has improved. So that I'll give it that. It's using length, which is the correct one. And okay, so that is better than before. I was criticizing it, saying it's not using the math functions. We've got it to do that. But what we need to do is to tell it. If I save that, I just say added a comment to use the maths RS square root. Can you update memory to say use this sort of shader style maths sort of free functions where possible. It's just my preference. But also add to memory that, you know, like try, always aim to reuse as much existing code as possible. And try and make sort of tight algorithms that are like sort of powerful. This is a very vague thing, but it's like, I think it's sort of smaller code is easy to keep in your head, right? And Claude is sometimes expanding lots of code. You know, sort of easy for me to keep in my head. So like fewer lines of code is good, because it's just conceptually it's easier for me to follow. But other than that, I think the plan seems decent. And also this is quite nice because now it is you know, the main body of the code is, this is fairly sort of a little bit more compact than what it's been generating before. And I think I'll just notify Claude about that. The current plan looks decent aside from the single comment I added. And I would say algorithmically this is good. This is like a sort of a digestible size that I can work with. So fewer lines is good. I also think I'll say, can Claude put that in the memory? It's like I would prefer to go, we would break down the plan into smaller digestible chunks. Like if we do need to with more complexity, I would like to be able to like accept more like digestible size chunks, and we can slowly we can build it up so we can build it up step by step and test it in between. You know, this is more how I would work, you know, manually. And I think the step by step helps to build better intuition. And evaluate the code. Can you add this to memory? Right. So, I think we got some good stuff there, and I think I am converging, hopefully, on a little bit more of a way that we can work together, me and Claude. Hotline patterns with square root preference. Yes, it's made that change. Update the plan square root. Actually, I can save memory files since they're not part of the code base, but the system only files you're allowed to edit is the plan. I'll make the plan edit now and save memories after exit plan mode. Exit plan mode in camel case. That must be that actual Claude's code. I just need to nip to toilet. I'll leave this going. Should we accept it? I'm going to accept it and I'll go for a wee. Back. Just checking the Tottenham score. 0-0. 1 point would do pretty the world of good at the moment. I don't even know the lineup. Okay, here we go. Clean, build, occupied cell, all of that kind of stuff. Let's get back in coding mode. So what we have now is like, can we put down an agent? Oh yeah, that's good, because they're like, basically they're sticking. Obviously they wouldn't spawn on top of each other, but collision. We've done it. Well in, Claude. Thank you very much. That was successful. Feels good. And we've got the collision around the corner. Obviously they're moving. Happy with that. Very, very happy. So now obviously you're going to get crowded. Wow, this is good. And I think this was a good example. We iterated, changed the plan, and I was happy. I'm happy with that result. And it doesn't feel jittery. There is some pushing, natural movement. But I kind of want a pushing effect. Obviously, people might fall off the platform, and that would be a condition for the game failing. But, you know, there's a decent number of agents in the game here. And they get stuck, but they're kind of waiting for people. It's just kind of, you know, a natural crowd sort of behavior is emerging. Wow. Game dev is fun. I bloody love it. I don't really make much games at work anymore. I do, you know, engine stuff and graphics and SDK stuff. And, you know, sometimes just a good old bit of gameplay mechanics is fun. Right, so we got collision. The wall system is kind of nice. What I really want now is we need to have multiple destinations. So, actually, let me see if I can... Let's see if we can get Claude to fix this issue with the control. How long I've been going? 82 mins. Oh, this is fun. This is fun. This has been good. This is good. Actually... Oh. I want to just check something that... Do they still have separation? Because they should kind of spread out. Right, it might have just removed... It's resolved something, but it's removed maybe a key thing we actually needed. Well, we have... Oh, mate. It's generating sepvel, but it never gets used. Oh dear. We still want that. This is funny. It's like a case someone told me about is like someone was like, "Oh, the tests are failing." And then Claude was like, "I fixed the tests." And it just deleted the tests. Oh, Tottenham are losing. Anyway, Claude. Yeah, this now control is not working. So, that's the wrong one. Get back to my other one. So, setvel is gone, but we kind of setvel is gone and no longer used. I do still want it. Because in low density, you don't want the agents to bunch together. So can we just add it back? So basically, like, so we'll get the setvel back, and oops, this is annoying. The default should be placing agent, and there's a bit of an additional collision, or is it? Yeah, I know what I want to do. The agents should rotate to their desired velocity. But I'm fairly happy with this. What we want is a less rigid movement velocity. So I want to get this looking a bit better. So yeah, I want to get this looking a bit better. Let's have a think. I think I would like the agents. So here, just trying to think about a good way to break this down. So when an agent is moving, you want to rotate to face the direction you're going. Like if you're going like this, the square, you would be pointing in that direction. So that would, obviously that gives them a bit more kind of cohesion, like what do they call it? Coherence, is it? That's in a Boyd system. So, you want to be facing that direction. And if it were an arrow, obviously if it were a square, which these guys are, the square would be like that. And then when you're this direction, you would be like that. So we want a rotation aspect based on the velocity. But also, if we're going like here, we're going this direction, and here we're going straight down, we want to kind of interpolate to that direction. Interpolate instead of it directly snapping. So then they would smoothly turn. But also, in the case of the wall collisions, which I was explaining earlier, you'd probably want a bit of strafe, maybe. But maybe we'll add strafe later. I think, yeah, that this will be okay. Let's go. Oh no, stop. Did you mean to send something more? Yes. I want to add a smooth interpolation between the sort of no, I want to add a like direction sort of system to the agent, direction concept to the agent, so they rotate to face the velocity direction. This should be smoothly interpolated. So they need a desired velocity and a sort of, so they have a desired velocity and the direction. Direction is the velocity, and then the current one. This will give it a current velocity or direction. This would give smooth. What is it? It's like smooth. Turning circles. We can add strafe. We can add strafe later, which would be used sometimes to avoid, you know, collision or. So yeah, we want that kind of. The cube mesh should rotate. So we can sort of visualize. Right. Okay. So, this is fine. We'll get Claude to do this. Then we have rotation. We have separation back. The jitteriness is okay. We can see there's some jitteriness. Yeah, I think I want to get directional stuff because what I want to put in is multiple destinations, and then we'll have the agents that go past each other in different directions. That could possibly lead to a deadlock, you know, where they block each other and some of them can't get through. But eventually, it probably, I don't know, it probably would work itself out, I think. But I think that's a good next step. We'd have multiple destination. And that is fun. Look at this. Loads of them. Performance seems okay. 16 milliseconds on CPU. I mean, there's not tons. But I think the sorting's good. There's some definitely, we need to go back through and comb through these algorithms. But this is turning into crowd sim, right? Come on. I bloody love coding. Even with Claude, even though I was annoyed at the start, I'm happier this time. And that's because I went away, I'd learned, but also I'm still writing my own code as well. It's important. We still need to do that. This guy's stuck. This guy's been pushed into a collision. Ooh, interesting. Right. Where is the plan? Is it because if we do this... I don't know why this is happening today. Why it's doing it in the file instead of just in the response. Update agents. So here we go. The plan is... this is fine. What we need to do is we need another wall collision pass after. You know, because we can resolve the collision here with the walls. Anyway, that doesn't... in overloaded situations, we can get pushed inside a collision. Or did I place one there? Oh no, you can't. It might have been a false scenario, but still... how many agents are in here? A little counter might be nice. I think there's like, let's see, 10, 20, 30, 40, 50. There's hundreds. There's over 100, I reckon, there, easily. So we're in the hundreds, and performance is nice, 16 milliseconds on the CPU. Okay, yeah, I was in the middle of this. Sorry, I've losing momentum. Okay, so update. It's not that much code. Smooth interpolation. F32 8 and 2. And constants tau. Constants tau. Turn rate. Do we not... What? Facing 0. What is facing? Facing angle. Current facing direction in radians. I think we should be just using quaternion for this. Because we construct quaternion from facing. We should be using the quat interpolation. That would make sense, right? So Claude is, again, I said, you know, when I said add it to memory, use the mass library. And it's doing its own thing. Okay, can we use, so, you know, 2 quaternions and then use slurp instead of manually, you know, constructing, you know, quat from the facing direction, since, you know, that's what the quaternion's there for. Also, we should have, I think, MathsRS should have tau. Again, please use MathsRS. You know, that I want to use. Booping, transmuting. Transmuting is interesting because that is Rust. You can do a transmute. But this is turning out to be good. Claude is helping. I think code-wise, there's still stuff we need to revisit. What's that one? Claude's plan, okay. I actually prefer the MD version of it for some reason. I guess it's like a bit more syntax highlighty, you know? So yeah, basically we need to go through all of these things and clean up, because some of these diffs and accumulation, separation. They do nlerp. Nlerp, should it not use slurp? So it's added that, which is slurp nlerp free functions. Yeah, I fixed those actually in MathsRS, and it's been published. So I can tell Claude to update the dependency. So MathsRS has been updated in the outside world and fixed the issue with the slurp nlerp. You can update it to version 1.0.0. And an interesting one on that, on maths, Claude was very good at helping with code review for it. And it helped me find some bugs and helped me basically get it to a shippable 1.0.0, which was, yeah, quite nice. So despite me starting this with my critique of the code generated by Claude, it has been, you know, it has been fun. Like, you know, it has been good, but also sometimes it's not good, you know, simultaneously, which is weird and kind of hard to describe. So let's see how they do it. Update agent transforms, facing. We have facing. We do nlerp. I'm not sure nlerp is correct, because, well, could we? So turn rate, that's fine, 0.1. Directly, no helper needed, which is cool. Reset register, get unchecked. Correction snapshot, correction write back. Okay. So vel length, so we have total vel, and then we basically, so if we have a a non-small. See, this is interesting. It just did a 0.01. It didn't put a const for that value, which is fine, but it's just weird. It's an obsession with making everything consts, like turn rate, but then it just has a magic number it drops in for that. Your footy checks. A102, F32, quat from Euler, and then facing. And we go, and we always lerp at that. No manual angle wrapping. nlerps dot flip handles the shortest path. Does it? Interesting. Well, that's cool. Well, this is nice and easy, and no delta or tau wrapping needed. Quat lerp. Yeah, exactly. See? Nice. Right, we got there. We got there. Yes, this is good. Yes. Yes, and auto accept. This has been a good session, even though like things are moving slowly, but I'm working through it. We're looking. I feel better. I feel much happy with the code that I've accepted today. The changes have been detected in here. Is it going to reload it? Somehow stuck. Oh, we've crashed. I think that's because we updated the maths lib and there's an issue with hot reloading the. Oh no. Oh, mate. Claude's generated a full-on crash here. Ooh, no. It's still going. Oh, I see. It's probably incomplete or something. I thought it had done it. And that's also the problem with because it's editing the code and it's accepting the changes, the hot reloading of the engine was detecting those changes and compiling in a bad state. So sometimes the changes we're making are a bit more breaking than others. I've been going for a while, almost 2 hours. Okay, so let's see if we can run it now. Clean build. Ages now has facing rot, and we smoothly interpolate to it, but it's crashing. Still crashing, mate. Panicking. Panicking at library core. Panic in a function that cannot unwind. So it's a bit weird. It's in the setup function. Set up rat race 2. Something to do with the well, I can run it on a debugger, maybe, but I think it's like... It's just Bevy crashing. Ah! I need to maybe just build the... I was building only the client. Session info. No, it has built it. Resource conflict. That wasn't... It wasn't doing it before, though, and that should be fine. It's fine. No. It's working now. I didn't build workspace. I think plugins were stale. I think. I thought it was that. Well, it's not crashing now. Oh, that's the wrong thing. OBS. Oops. Which I'm just gonna bring that back across. Okay. Okay. So let's see. Can we place an agent? Okay, look. They nicely rotate. They smoothly rotate. They get a bit of collision. Now they have a bit more personality to them already, you know? So that's fun. And they seem slightly off a little bit. Ooh. They were spinning or jittering. The spinning around, I think... Oh, I think we need slurp. That slurping's going to fix it. I said to use slurp, and it was like, I'm going to use nlerp, right? There's a reason for doing it, and I don't think the nlerp is... They shouldn't be doing that spin, for sure. Get rid of that. Rat Race 2. nlerp. We're doing slurp, mate. Let's see how slurpy. Slurpy game dev. Right. Oops. That's something that I want badly. Yeah, they still kind of get pushed on the corners. They have that extra velocity, which is a strafe, but we can they're not as badly rotating, but there's still some weirdness. I think it's just the jitteriness. We need there needs to be a stage which is going to be a pass where it's kind of they're waiting, they're queuing, and a queue kind of is going to be a bit more stable and resolve itself. That's fine. I think at least the core thing here, we have the rotation in, we have the collision in, we have the wall avoidance in. Okay, and yeah, we need to sort out the collision map. I'm not going to do that today. So it's like when they're in a crowd, they would step backwards. You don't always rotate. In general, you would rotate where you're going, but there's going to be some sort of amount of strafing. Right. Almost 2 hours. I think 2 hours has been how long my sessions have been in general. But let's just see. Can we add multiple agents? We're going to have multiple agents with different destinations. Yeah, I think maybe this is potentially a decent place to leave it. A couple of hours work. I could do with getting some food. I'm a little bit hungry. So I think I'm going to sign off. Right. For the day. But, yeah, before that, I think I'll just do a little summary here that started the session complaining about Claude because I wasn't happy with the code it's generated. And by working on it myself, I've uncovered some solutions to what I wanted to do. Coming back this time, I think I was able to steer Claude a bit better, but still, I feel like the initial plan that it's doing isn't, it definitely needs more iterations. But what I definitely feel about this time is that I'm happier with the code that I want. I want to jump in, and that's the main thing I wanted to get from this. I don't want to just get Claude to do the whole thing. I don't want to do the whole thing myself. I want to be able to collaborate a bit more, and I think that there was a bit of barrier previously, and now I think I'm pretty, happy with the code it's done today. That I'm gonna probably take a look at this. Maybe I'll do a midweek session, kind of manually planning a bit, and then we can come back. And then the next things to do is like multiple destinations, so you've got agents going in different directions in the game, and then that's going to create a bit more of a different kind of contention, some sort of collisions. We need a bit more of a resolve of the collision detection algorithm, but I think this has been really good progress, so I'm going to call it there. Have a good one. Bye. If you're watching this, if you've made it to the end, no one's going to have made it to the end, but check out the repo on GitHub, give me a sub or whatever, and come back and see how I'm getting on.